a lot for this very nice introduction. I think it hears very well when someone reads my short bio, much better than actually it is. I'm just a hard worker, I would say, more than a superstar. Um, but yeah, and thanks a lot for the invitation, and I'm really happy to give this talk today, especially because I would like to give like a very generic overview of what we are doing in the ontology matching community that falls more into this semantic web community, and see if we can find more synergies with the life science community, which is something, of course, we have already started, but I think we can get closer to each other. And yeah, and this work has been doing with Thomas Liner and Ian Harrow from the Pistoia Alliance, where I keep an active collaboration. So yeah, I'm not gonna fall into very specific details of the ontology matching community. As I said, I would like to give an overview with some interesting pointers, and then possibly write some discussions and collaborations for the future. And first of all, I would like to give a very quick introduction to what is ontology alignment for the ontology matching community, especially because we have different ways of referring to the same thing, and always we have like a funny discussion with Ian Harrow, no, trying to understand what we mean with mapping or alignment. So for me, an alignment or ontology alignment is the process of finding correspondences or links between ontologies. And then, of course, when we refer to match or to align or to map, is the process of producing such an alignment. Now you will also find, apart from onto alignment or ontology matching as synonyms, also knowledge graph alignment, which I would say that is a subtype of onto alignment, most probably focused on entity alignment, no, more at the data level, and so on. And then also we refer to mapping to a single element that belongs to the alignment set. This is the basic formalization we have in the ontology matching community. So basically, an ontology alignment is a set of mappings, and each mapping is composed by a couple of entities. They come from the input ontologies, and entities can be classes, properties, or instances. Then typically, every mapping has an associated confidence, especially when this mapping has been discovered by an automatic system, and also has an associated relationship. And here this fits very well to what David was introducing before, no? In the ontology matching community, we have different ways to refer into this relationship, typically closer to what you would say in OWL, while in other communities, the relationship, I would say, is more relaxed. No? It depends. And this may cause problems, as David was highlighting, like which are the clear semantics of the mapping. And it's not something we have solved in the ontology matching community either. No, this will depend on the interpretation that you give, the final interpretation you give to the mappings. And yeah, linking to this, in the ontology matching community, we have an exchange format that is called the RDF Alignment format, and it's very basic format that captures the entities, the confidence, and the relationship for each of the mappings, without providing any additional formalization or interpretation of the real semantics of the mapping. In the same line, Nico will present later, the simple standard for sharing ontology mappings, which I really like because it includes more information apart from these 4 elements in a mapping. So it contains very relevant information about the provenance, so that who created this mapping, was automatic mapping, was something that a human created, was a lexical like mapping, and so on. So I think this is very important. And I had a feeling that, or at least I would like to adopt this standard for the ontology matching community too. And that's something I especially like, given my background is providing clear semantics to the mappings, and that's why an additional way to exchange mappings would be giving them clear semantics using OWL axioms. And the good thing or the positive thing of this is it will enable OWL reasoning and you could use all the infrastructure that is available in the semantic web community, but at the same time, it provides a very strong assumption and interpretation for some mappings, which maybe you are telling that they mean like a out to equivalence or substantiation when they are not really meaning that. So in this sense, we should be careful, as I will show you an example later. And then, yeah, that would be a very generic representation of onto alignment system, where it gets as an input two ontologies and produces an alignment as an output. And optionally, it could also get as an input a parcel alignment, some parameters, and some background resources. And then, yeah, coming to what I wanted to present today, like the effort we have been doing in this Onto Alignment Evaluation Initiative. It's an annual campaign that started way before I started my PhD. So this has been running since 2004. I joined this campaign as a participant in 2011, and then later in 2012 as an organizer. And I think we believe that we have been helping system to improve the performance, and also providing different data sets to evaluate them. Has been mostly driven by academia and mostly driven by the semantic web community. And this is why this Ontology Matching workshop is co-organized annually with the International Semantic Web Conference, but has been also supported by, at least recently supported by industry, and examples are IBM Research, Pistoia Alliance, and SIRIUS. And yeah, these are the main objectives of the Ontology Alignment Evaluation Initiative. Like, the idea is to create like a common framework to evaluate onto alignment systems under the same conditions, so that we can identify not only who is the best, that sometimes participants get very competitive, but also the idea is to improve systems, to analyze which are the strengths, weakness, also create some sort of community, to help each other, and also, of course, trying to improve the evaluation over the years. This is just an overview of the schedule we have every year. So we start preparing the campaign in June, more or less, although I try to start pushing the organizers around April, May. And then data sets should be ready by June, so that we leave July and August with enough time to participants to fine-tune their systems. And then finally, the organizers, they perform the evaluation during September and sometimes also in October. And finally, we present the results during the Ontology Matching workshop and the conference. And something I would like to highlight as well today is, like, we are open, we are quite open and dynamic community. So we are always happy to hear, especially from domain experts, like new use cases and data sets, and possibly new organizers. Like, if you are bringing a new data set, we are going to be more than happy if you become one of the campaign organizers. So please get in touch if you have something in mind. And that's something that is very important. I don't know if it was clear before, like, we as organizers, we run the system. So what we are very interested in being able to reproduce the results. So we have an evaluation platform that has been evolving, and this year we have a different one, where this platform allows us to run the system, given some ontology matching task as an input. And then it produces, well, we have in some cases some reference alignment, and we're able to produce some metrics out of the alignment task. And those metrics are the standard precision and recall, but we also focus on logical errors and computation times. And as mentioned before, I really like trying to give proper semantics to the alignments. And then, of course, if you assume that the mappings that a system or mappings that are available in a repository can be interpreted as all axioms, if you put everything together, input ontologies plus alignments, then you will most probably get some problems. I really like that there are some systems like KBoom and Boomer that are trying to deal with this problem. And I think it's key for this synergizing, to at least to lead or drive this synergies, how to synergize ontologies. And it's something I have been pushing also from since my PhD. And then, of course, one could try to address or face those logical problems applying different solutions. Like, one classical solution is trying to fix the mapping, so trying to find incompatibilities and see, like, if you finally get an integrated ontology that doesn't contain errors. Another alternative is trying to modify the ontologies, which might not be possible. No, the ontologies are not. You are not the one maintaining the ontologies. Maybe you can propose changes, but this second solution that is a bit more conflicting in that sense. And the final solution is also, depending what you like to do with alignments, being aware which are the limitations. If you like to do query answering and reasoning, then possibly you need to avoid incompatibilities, but otherwise maybe the alignments can be fine if you don't want to do reasoning. That's something to keep in mind. And this is the overview of the tracks we have in 2020. We have probably the same numbers of tracks this year. So last year we have 12 tracks, and then 4 of them were bio-related tracks. And I'm going to give you a very quick overview because I think I'm already running a bit out of time. So we have one track that is the classical bio track in the campaign. There is anatomy that involves the adult mouse anatomy, an old version, and an old fragment of the NCI thesaurus dealing with human anatomy. The good thing of this track is it contains manually created mappings, and this is why we kept the same versions of. I think they're already more than 10 years old. Another track that I introduced in 2012 was the large bio that included FMA, NCI, and SNOMED, and it was called large bio because I wanted to push the limits of the state-of-the-art systems back in 2011 and 12, because they were able to cope with anatomy track more or less. But then when I brought a SNOMED that was 100 times bigger than the anatomy ontologies, then this was causing some issues. And then the reference alignment relies on the UMLS mappings. We also had this biodiversity track that started in 2018 and deals with different environment and earth ontologies. And it contains it used to contain 2 tasks, and I think now it contains 3 or 4, if I'm not wrong. And finally, from the campaign, we have the Disease and Phenotype track that has been running since 2016 in collaboration with the Pistoia Alliance, and where we try to map phenotype ontologies and disease ontologies. And then what I really like from this track is we don't have a reference alignment, and what we are trying to do is building a consensus alignment using the system computed mappings. And this is very close to what you will find in the real world. You don't really have a gold standard, unlikely, of course. And so you need to find something that it gets closer to this desired reference alignment or reference alignment, ideal alignment between the input ontologies. So in this track, we are trying to build this consensus alignment by what the systems are proposing, and we create some sort of voting. And then as an example, here we created the consensus with both 3, and you can see the percentage of the contribution of each of the systems. I think that's quite interesting. Just to give you an overview of the different systems that participated in the campaign and how they contributed in creating this consensus alignment. And this, as I mentioned, this falls to a real situation, where you would like to start automating the matching process. So it's good to rely on some automatic alignment systems and possibly the consensus of those alignment systems, and then after that you can build with some manual revision. And yeah, not all the systems are easy to use or they're open source or available, but I give you some examples here that LogMap and AML are like long-running systems in the campaign. They're available, and they provide also a simple interface as well, apart from being able to be run a command line or in Java applications. And then if you refer to the evaluation campaign webpage, you can find other systems. And then talking to very important point, we have been dealing with some challenges in the campaign and in the ontology matching community, and I think we have been doing great in some of them, like being able to cope with large ontologies, large and rich ontologies. We are relatively good in using background knowledge, like getting some information from BioPortal, for example. But in other aspects, I think the community needs to do a bit better, no? Like how to deal with these different modeling views and to deal with these logical errors in the integration. And also how to involve the user, no? How to involve the user in the sense like getting feedback to improve the alignment somehow, no? Like having some sort of interaction. I think it's something we have a track in the campaign, but we can do much better in this line. And I think here I put in red, no? Some aspect that we are doing things, but I think we can do much better. And I think we need more systems and evaluation to for complex mappings. And also in relation with this, probably we need to bring more machine learning techniques in this world. And then finally, I think we need better connection with real world needs. I think we have some, for example, some bio tracks, but I think we need to get closer and closer to what the real application is in need, no? And this is also one of the motivations why I'm here, and also why I was very happy when the Ian Harrow approached to me from the Pistoia Alliance and see how we could collaborate, no? And then for the ones who doesn't know what is the Pistoia Alliance, it's a not-for-profit organization involving mostly industry but also academia, and is running different projects. And one of the projects is the Ontology Matching mapping project that tried to provide solutions to match life science ontologies, specifically in the phenotype disease domain and also in the laboratory analytics domain. They're having several outputs. I think the best thing is you can access the project webpage. We have been running the Disease and Phenotype since 2016. Also, as an outcome of the project, they implemented Paxo. It's a lightweight algorithm using the EBI's infrastructure that David introduced in the previous talk. And also we have been working on this creation of consensus mapping for different tasks by running different alignment systems. And now recently this Ontology Mappings project has been integrating within this FAIR implementation project to have like a more global picture. And it fits very well because to enable FAIR principles, ontology mapping will play a key role. And yeah, that's everything from my side. I think I was running a bit late, but not much. So yeah, in case you would like to know a bit more on what we have been doing in ontology matching for the biomedical domain, we ran a tutorial 2 years ago that is quite interesting. Also in collaboration with the Pistoia Alliance and the EBI. And yeah, I think there are some questions already in the chat, if I'm not wrong.
Yeah, thank you so much. Yeah, thank you so much, Ernesto. Fantastic talk. Really amazing in technical detail. So we're almost out of time, but let's at least read the questions, and then you can very briefly address it or follow up later in the breakout session. But from Nico. Ernesto, one thing I noticed is that the matches get more and more sophisticated, spreading logical axioms, lexical information, and some of your recent work, even machine learning. Do you see any hope to get the matching tools to natively support string metadata format like SSSOM and actually emit the mapping justifications? For example, mapping 1 was due to lexical match, mapping 2 was due to logical map, synonyms, and etc. etc.
I think so. I think that would be very interesting. I mean, talking as also system developer, no, we have LogMap, and LogMap has different set of mappings, and that in the end it produces as a single output. But then that could be organized in a better way, you know, using this standard, trying to add some additional metadata and provenance. No? Like this mapping was pure lexically computed, and some other mappings I explode a bit the neighborhood and things like that, or adding some. Because now everything is condensated into a number that is the confidence, which it doesn't say much, especially in the case of LogMap, if I'm honest. So if we translate this into this standard, I think will be great. And also if we push other participants to do the same, I think that would be a very good idea.
Yeah, great. And then Melissa, I just want to read the question at least. So the question is, how do you choose the ontologies to base the alignment on? What's the impact of choosing the two ontologies that are co-developed, you know, and then how do you use like kind of Uber level ontologies, right? So utilize like Uberon or Mondo or something like that.
Yeah, that's a good question. So we originally the large bio, I chose the ontologies because they were large and there were some mappings available. No? There were some overlapping. I didn't take into account like how independent they were. In this case, I think FMA and SNOMET and NCI are quite independent. But in some other cases, I agree. They might be easier to align some ontologies because they use the same naming convention, for example, and same structure. So the motivation for the phenotype track, as it was given by Pistoia, that were the core ontologies we wanted to provide some mappings, and also not only phenotype, disease, that is what is in the campaign, but also we try to map disease to phenotype and so on. And the same for the laboratory analytics domain. There were some voting of which was the main ontologies covering the domain, and then they were the ones we chose. But that's true that that's a different dimension to take into account, no? Like to evaluate how complex is the mapping. So yeah, something we will take into account in the future as well. And also, yeah, I mean, all these ideas are very welcome for the campaign.
And yeah, I think there are a lot more questions and comments, you know, about how you resolve the issues and all of that. But let's keep that discussion for a little bit later. Or of course, you guys can of course chat, you know, interact via the chat or offline, right?